Good morning, welcome to Sakar Vijay YouTube channel. I hope, am I audible to you, all of you? Visible? Fine, okay. Am I audible? Yes or no? Right. So, very good morning. So, welcome to the today's session. Okay. So, in the last class we have completed, okay, 50 problems. 50 problems. Okay, thank you. Now, 51st problem. 51st problem. Fine. Yes, okay. 51st problem, we need to complete it. 51st problem. 51st problem. Audible. Okay. Aningi Bhaskar Rao. Okay, let us wait for 2 more minutes. Okay. Good morning, everybody. Very good morning. Chintu. Suma. Good morning. Satvik. Balu. Swati. Prasanna. Narla. I will decide. Okay. Metta Revati. Mahalakshmi. Okay, Rupa Reddy. Let us start. If omega does not equal to 1 is a cube root of unity means 1, then det of 1 plus omega square 1 minus I minus 1 omega square minus 1 minus I minus 1 plus omega minus 1. Okay, this is the minus 1 plus omega equals to first option 0, second option 1, third option I, fourth option omega. Unless it is mentioned, sometimes omega may not be a other complex number also, unless it is mentioned. But in general, that is the cube root of unity. Other than that is the imaginary cube root of unity. That's omega. Okay, Vamshi Krishna Yadav, actually one time is enough. You need not give more number of times. Right, let us go for this problem now. Right. See, omega is a cube root of unity, then we need to find out this determinant. Okay, let us find out. 51 solution. Given expression is nothing but the determinant of 1 plus omega square 1 minus I minus 1 omega square minus 1 minus I minus 1 plus omega minus 1. So now tell me what sort of operation need to be applied for this one in order to find out easy manner, in order to expand easy manner. So now my strategy, I would like to do 1 plus minus I, 1 plus omega square plus minus 1 omega, minus 1 cancel, omega square plus omega, that will be minus 1. This becomes 1 minus I minus 1 omega square minus 1. That means R1 and R2 becomes identical. R1 becomes identical, then we get the determinant is equal to 0. So that means now apply R1 is replaced by R1 plus R3. Now this is equals to 1 plus of minus I, 1 minus I, 1 plus omega square plus minus 1 omega, minus 1 plus 1 cancel, omega square plus omega, omega square minus 1, and next 1 minus I minus 1 omega square minus 1 minus I minus 1 plus omega and minus 1. See, we have, since 1 plus omega square is equal to 0, this omega plus omega square equals to 0 minus 1, minus 1. So now we can write this is equal to 1 minus I, this omega square plus omega is minus 1, omega square minus 1, 1 minus I minus 1, omega square minus 1, minus I minus 1 plus omega minus 1. Now what do you observe? Yes, we observe that here R1 is identical with R2. Since R1 is identical with R2, the determinant of this matrix becomes 0. So answer is 0. That means let us move to the option. The first option is the right option. And once again, all of you check the solution. This is the solution. Right. Right. (52). Question number 52. If omega is an imaginary root of unity, then the value of 1 times 2 minus omega times 2 minus omega square plus 2 times 3 minus omega 3 minus omega square plus so on dash dash plus n minus 1, this is n, sorry, n minus omega times n minus omega square equals to, first option is 1 by 4 upon n times n plus 1 whole square minus n. Second one, n times n plus 1 upon by 2 whole square plus n. Third option, n times n plus 1 upon 2 whole square minus n. Fourth one, n times n plus 1 by 2 whole square minus n. This is the question. 52nd question. If omega is imaginary root of unity, then we need to find out 1 times 2 minus omega times 2 minus omega square plus 2 times 3 minus omega times 3 minus omega square plus so on, plus n minus 1 times n minus omega times n minus omega square. That we need to find out. First option, second option, third option, fourth option. Okay, let us do it now. 52 solution. 52 solution. Now this given expression can be written as sigma r is equal to 1 to, here see, here r is equal to 1 to n minus 1. So we can write r is equal to 1 to n minus 1. General term, let us write it now. You observe it now here. For example, here 2 is there, 2 minus 1 we have, 2 minus 1. Here 2 is there, the 2 will be 3 minus 1. Here n will be there, n minus 1. So in general we can write rth term. Rth term means we can write like this. R times, we can write R times, here r plus 1 minus omega, r plus 1 minus omega square. Don't worry, I will explain. Let me explain. Don't get any confusion here. So that means, for example, if you put 1, what do you get? You check it now once again. If you put 1, you get 1 plus 1 is 2, 2 minus omega and 2 minus omega square. If you put r is equal to 2, what do you get now? 2 times 3 minus omega plus 3 minus omega square. Understood now? That's why this is the general term. General term. So you need to multiply these 3. You need to multiply these 3 means, so this can be rewritten as sigma r is equal to 1 to n minus 1. This r can be written r plus 1 minus 1. R plus 1 minus omega and r plus 1 minus omega square. So yesterday class we have discussed one beautiful concept that let me explain once again. So that result we need to make use of. Let us say r plus 1 equals to x. Now this becomes x plus minus 1 times x minus omega times x minus omega square. So for your clarification, let me do x minus 1 into product of these two is nothing but you get like this, x square plus x plus 1. It is one of the important algebraic identities are to be addressed now here. So x minus 1 multiplied by x square plus x minus 1 is x cube minus 1. So with the help of this, what does x stands for here? R plus 1. So this can be written now, sigma r is equal to 1 to n minus 1 runs over from 1 to n minus 1. This product is r plus 1 whole cube minus 1. So we can split sigma r is equal to 1 to n minus 1 r plus 1 whole cube minus sigma r is equal to 1 to n minus 1 1. So this we can write now, r plus 1 whole cube means put r is equal to 1. 1 plus 1, 2 cube. Sigma means summation, plus you will get. Now 2 plus 1, 3 cube, 4 cube, and plus so on dash dash. If you put n minus 1 plus 1, that will be n cube minus sigma 1. 1 is added for how many times? N minus 1 times. That means 1 plus 1 plus 1 plus so on n minus 1 times. So this we get now 2 cube plus 3 cube plus 4 cube plus so on dash dash plus n cube. 1 multiplied by n minus 1 times is minus of n minus 1. Minus into minus plus, so that we can write 1 means 1 cube, 2 cube, 3 cube, and so on dash dash plus n cube minus n. Here very interesting factor that actually, see, this is nothing but sum of the cubes of the first n natural numbers. That is nothing but sigma n cube. Sigma n cube minus n. Sigma n cube is nothing but n into n plus 1, n square, n plus 1 whole square upon 4, and already this minus n is there, minus n. This is the answer. This is the answer. Right? Okay, all of you check it now. It's not an easy problem. It is a level 2 problem. Today, where is Maulana? Yesterday she asked so many questions regarding the typical questions. Today we are going to discuss typical questions only. Okay. This question is the connection between algebra, complex numbers, and progressions. The 3 chapters are there in this one. (53) Question number 53. If 1 plus x square whole to the power of n equals to a0 plus a1x plus a2x square and plus so on dash dash a to n of x to the power of 2n. X to the power of 2n. Okay, Prasad, I will explain. Okay, you have another method. Just you type in the comment section. Right. 1 plus x square whole to the power of n equals to a0 plus a1x plus a2x square plus so on dash dash plus a2n x to the power of 2n. Then the value of a0 plus a3 plus a6 plus dash dash equal to first option 1, second option 2 raised to n, third one is 2 raised to n minus 1, Fourth one is 3 raised to n minus 1. Right. So now 1 plus x square whole to the power of n equal to a naught plus a1x plus a2x square plus so on plus a to n x to the power of 2n. Then the value of a naught plus a3 plus a6 and so on equals to, we need to find out. So this means actually here see the solution follows. So given 1 plus x square whole to the power of n equals to a naught plus a1x plus a2x square plus a3x cube a4x to the power of 4, am I correct? Plus a5x to the power of 5 plus a6x to the power of 6 plus dash dash plus a to n x to the power of 2n you can write. Say equation 1. Okay. Here first this question need to be done, but actually in the examination don't do it. You remember this one. 53rd answer is fourth option. 3 raised to n minus 1 is the answer. 3 to the power of n minus 1. You remember this one as the result better in the final examination. Answer is this one. Okay, but I will explain the method, don't worry. Because I will explain the method, but you need to remember this one as the result. These results need to be written in a separate notebook. While going to the examination, just go through the question. This is standard result. Okay. So now 53 solution. 53 solution. A naught plus a1 x plus a2x square plus a3x cube plus a4x to the power of 4 plus a5x to the power of 5 plus a6x to the power of 6 plus so on dash dash equal to a to n x to the power of 2n equals to 1 plus x square all to the power of n. This is given. Say equation 1. Now here put x is equal to 1. If you put x is equal to 1, what do you get now here? A naught plus a1 into x, a1, 1 square also 1, plus a2 plus a3 plus a4 plus a5 plus a6 and so on dash dash equal to 1 plus 1 plus 1 plus 1, that is 3 raised to n. Say this is equation, better you say this is equation 1. So you leave this one. Okay, this is first one. But here we are not asked to find out sum of all the coefficients of this expansion. Sum of the coefficients of expansion. Sum of the coefficients of expansion means that's all. Answer is over. 3 raised to n. But we are asked a0, a3, a6. This a1, a2 must be skipped. A4, a5 skipped. a0 plus a3 plus a6 we need to find out. That's why next substitute this time. Put x is equal to omega. If you put omega, first one is a0, next one is a1 omega, next one is a2 omega square plus a3 omega cube. Omega cube means omega to the power of multiples of 3 is 1 we can write, so a3. This will be a to the power of 4 omega to the power of 4. Omega to the power of 4 directly I will write omega plus a to the power of 5 is omega to the power of 5, that is omega square, plus a power 6 omega to the power of 6 is 1, so a6 plus dash dash equal to 1 plus omega square whole to the power of n. This is 1 plus omega square is 0. So this becomes second equation. This becomes second equation. Now this time put x is equal to omega square. Very tricky problem this is. Now again a0 plus a1 omega square plus a2 omega to the power of 4. Omega to the power of 4 is omega plus a3 omega to the power of 6 is a3 plus this becomes directly a power 4 omega square a power 5 omega plus a6 and dash equal to, you get 1 plus omega power 4 is omega square and omega whole to the power of n. This is 0. Now adding 1, 2 and 3. See what do you get? Let me explain. When you add this equation 1, equation 2, equation 3. See vertically a0. So we get 3a0 plus here a1 is common. A1 is common means 1 plus omega square. Because omega and here omega square we have. So similarly a2 is also 1 plus omega square. Next we have a3. That will be 3a3. And so on dash you will be getting, this will be 3a6 dash equal to 3 to the power of n plus 0, 3 to the power of n plus 0, 3 to the power of n. So this will be 0, this will be 0. So that means this value is 0, this value is also 0 from the properties of the cube roots of unity. So now we get 3 common, a0 plus a3 plus a6 plus and so on equals to 3 raised to n. Now what do you want? We want the sum of these coefficients. So that is given by a0 plus a3 plus a6 dash equal to 3 raised to n upon 3. This equals to 3 raised to n minus 1. But I have given the proof. Please actually discard this proof in the examination. This proof is for your satisfaction. I have done for the sake of yourself. How do we get it? That I have explained you. How do we get it? That I have explained. Understood now? This is nothing but application of complex numbers in binomial theorem. See, the same question may be appeared in binomial theorem also. It is very important for binomial theorem also. This problem I haven't discussed in binomial theorem. I haven't discussed. So that's why I have discussed here itself. Yes, standard result now. I already given the solution, this one. 54. Yes, 54th question. If 1 omega square so on omega to the power of n minus 1 are the nth roots of nth roots of unity, nth roots of unity, then the value of 1 upon 2 minus omega plus 1 upon 2 minus omega square plus so on dash dash plus 1 upon 2 minus omega to the power of n minus 1 equals to okay, Akshita, Cheti, Govind, Sumant. First option 1 raised to 2 to the power of n minus 1. Second option n minus 2 times 2 to the power of n minus 1 upon 2 to the power of n minus 1. Third option n times 2 to the power of n minus 1 upon 2 to the power of n plus 1. Fourth option is none. This is the question. Okay, anybody? All of you look at the screen. Just go through the question first. Go through the question first. One minute. Right. See, 1 omega square and so on omega to the power of n minus 1 are the nth roots of unity. Nth roots of unity. Then the value of 1 upon 2 minus omega plus 1 upon 2 minus omega square plus so on plus 1 upon 2 minus omega to the power of n minus 1 need to find out. So let us find out. This is 54th solution. 54th solution. So let us say, see, x is equal to nth root 1. Raising the power both sides to 1, we get x to the power of n equals to 1. That implies x to the power of n minus 1 is equal to 0. So we get a equation of order, nth order equation, we shall get it. Nth order equation. What are the roots given here? Roots are 1 omega square and so on omega to the power of n minus 1. These are the roots of this equation. So that means the left hand side must be equal to, we can write like this. So we have this x minus 1 multiplied by x minus omega multiplied by x minus omega square multiplied by and so on x minus omega to the power of n minus 1 equals to, we can write x to the power of minus 1. Since they are the roots, roots means x minus 1, x minus omega square and so on x minus omega to the power of n minus 1 is equal to x to the power of n minus 1. Here one thing you do, apply logarithm on both sides. Apply logarithms on both sides. Logarithms on both sides. Applying logarithms on both sides, so product can become sum now. we get like this, log of x minus 1 to the base e only. This becomes log of x minus omega plus log of x minus omega square plus so on dash dash log of x minus omega to the power of n minus 1 equal to log of x to the power of n minus 1. So you may have doubt, why should we write like this? Because we have 1 upon 1 upon. So that means 1 upon is nothing but the derivative of the logarithm. So that's why I applied the logarithm. Now differentiate with respect to x on both sides. Differentiation of x minus 1 is 1 upon x minus 1. Yes, that's why I applied the logarithm. Plus log of x minus omega differentiation is 1 upon x minus omega plus 1 upon x minus omega square plus so on dash dash. The derivative of log of x minus omega to the power of n minus 1 is 1 minus omega to the power of n minus 1 equal to, the derivative of this one is 1 upon x to the power of n minus 1 times x to the power of n minus 1 differentiation is n into x to the power of n minus 1. Just you check the question. Question is important. In the question we have, see, 2 minus omega square 2 here, this is x. 2 minus omega to the power of n minus 1. Put x is equal to 2. So having been substituted x for 2, put x is equal to 2. So now what do we get now here? 1 upon 2 minus 1 is 1, 1 plus 1 minus 2 omega plus 1 minus 2 omega square plus so on dash dash 2 minus omega to the power of n minus 1 is equal to, here n times 2 to the power of n minus 1 upon 2 to the power of n minus 1. But we need this value. Say this is given expression, this value is. Now the given expression is equal to, we can write a given expression. Say this is given expression. This will be given expression. Equal to 1 goes that side. So this equal to n times 2 power n minus 1 upon 2 power n minus 1 minus 1. This we can write n times 2 power n minus 1 minus 2 power n plus 1 upon 2 power n minus 1. See, verify the options. In the options no such value is there. No such value is there. So that's why fourth option is the right option. So all of you check the solution. This is very different. I want to join in your academy. Okay, all the best. Okay. So these type of questions may be asked for the JEE mains examination. But after completion of the Eamcet syllabus, I am going to discuss these kind of problems. This kind of problems I will discuss. Okay. So no shortcut method. This is the shortcut method itself only, because it's a problem. How for every problem we cannot actually remember the shortcut. If you want to remember the shortcut, means option should be there. Option is not there in that one. If the option is given, we can adopt the shortcut. What is the shortcut means? Put n is equal to 2. If you put n is equal to 2 means what are the actually cube roots of square root of unity plus or minus 1. Plus or minus 1 means 1 will be 1, another one is minus 1 x. By substituting we will get it, but option verification should be done. But here option is not at all given. That's why it's a more typical task to apply the shortcut in this case. So if you have any shortcut, you can share with me. Okay, 55. Question number 55. If x square plus x plus 1 equals to 0, then the value of x plus 1 by x whole square plus x square plus 1 by x square whole square plus x cube plus 1 by x cube whole square plus so on dash dash x to the power of 27 plus 1 by x to the power of 27 whole square is first option 27, second option 72, third option is 45, fourth option is 54. Fourth option is 54. So Maulana Sheikh, it's not a paid channel, it's a actually free channel. So that means depending upon our interest or wish, we shall continue the classes, or sometimes we may stop the classes also. Because if you take the money from your side, then we are the responsible for that one. Understood now? Because only I can teach mathematics now, I have been continuing the mathematics classes. So that you need to understand. Right. See, x square plus x plus 1 is equal to 0. Then the value of x plus 1 by x whole square plus x square plus 1 by x square whole square plus x cube plus 1 by x cube whole square plus so on plus x to the power of 27 plus 1 by x to the power of 27 whole square is we need to find out. This question is very important. This question, let us try now. Let us try. Right. Now the solution. X square plus x plus 1 equals to 0. Here d equals to b square minus 4ac. So we get 1 square minus 4 into 1 into 1. 1 minus 4, that will be minus 3. Obviously imaginary roots. Okay. X is equal to minus b plus r minus root d upon 2a. So here minus 1 plus r minus root of minus 3 upon 2. This will be minus 1 plus r minus root 3i upon 2. So we can say the roots are omega and omega square. One is omega, another one is omega square. So now that means let us take now here, consider x is equal to omega. No problem. Let us consider one of the values. Now given expression can be written x plus 1 by x. X plus 1 by x means omega plus 1 by omega. 1 by omega, you remember, 1 by omega is omega square, because if you cross multiply you get 1 only. This is omega plus omega square. We have whole square plus next is omega square, 1 by omega square. That's also we can write omega plus omega square whole square. This is first term. Second term. Third term becomes very interesting. Omega cube plus, that will be 1 by omega cube whole square plus so on dash dash. Last one is omega to the power of 27 plus 1 by omega to the power of 27 whole square. This 27 is the multiple of divisible by 3. It leaves a remainder 0. That's why this is also 1, this is also 1. So that means you can write like this. See, minus 1 square plus minus 1 square, because omega plus omega square is minus 1. But see this bracket now, this bracket is omega cube 1, 1 plus 1 square, plus next bracket will be pink bracket, next will be pink bracket, plus next will be, you get a 1 plus 1 square, and so on dash dash. Last one also, omega to the power of 27 is actually omega cube whole cube, 1 plus 1 whole square. So this will be minus 1, minus 1. So now what we need to do means, how many minus 1 square are there, next how many plus 2 square are there, that we need to count in this one. That's very simple manner we can count. See, minus 1 square is actually, we have, this is 1 square 1, minus 1 square 1 plus dash dash, this color you put it, and plus this will be 2 square, 4 plus 4 plus 4, and so on dash dash. This how many we need to find out. So that means actually very clear, for every third term, next third term after sixth term after ninth term, and so on 27th term, you get this four values. That means very simple to determine here. Here multiples of 3 up to 27 you need to write. So how many multiples of 3 up to 27 means, very simple manner you can find out. Number is equal to, number of multiples is equal to 27 minus 3 is 24. Common difference is how much? 3 plus 1. So 8 plus 1 is 9. This up to 9 terms. 9 terms means total 27. Total 27 terms. 27 minus 9 is 18. So this will be up to 18 times. 18 terms. So this equal to, we can get 18 into, we can have 18 times 1 and 9 times 4. This is 18 plus 36. So answer equals to 54. This is the answer. Hello? One minute. I will continue the class. So this is very important problem. Just you practice it. So these type of models you need to practice. Once again you practice it. One minute I shall come. 1 minute. Now 56th question. 56th question. Question. If the cube roots of unity are 1 omega square, then the roots of equation x minus 1 whole cube plus 8 equals to 0 are first option minus 1 plus 2 omega minus 1 minus 2 omega square, second one minus 1 minus 1 minus 1, third one minus 1 sorry this is plus 1 okay plus 1, this is plus 1 1 minus 2 omega 1 minus 2 omega square, fourth option minus 1 1 plus 2 omega 1 plus 2 omega square. This is the question. Okay, this is the question. So all of you just look at the screen. If the cube roots of unity are 1 omega square, then the roots of the equation x minus 1 whole cube plus 8 is equal to 0. We need to find out. #56 solution. See, given x minus 1 whole cube equals to minus 8. This x minus 1 is equal to, we can write cube the root of minus 8. This we can write cube the root of minus 1, cube the root of minus 1 multiplied by 8. This we can write cube the root of minus 1 into cube the root of 8. So the cube the root of minus 1 equals to, see, cube the root of minus 1 equals to minus of cube the root of 1. So cube the root of 1 are given by minus of 1 omega square. So this we can write minus 1 minus omega and minus omega square. So one more thing, the cube the root of 8 equals to, this we can write 2 cube whole to the power of 1 by 3, that is 2. So now we can write this is 2 times minus 1 minus omega square. This we can write minus 2 omega square. Now we need to find out x value. So now x equals to, therefore add 1 1 minus 2 omega 1 minus 2 omega square. So this is equal to minus 1 1 minus 2 omega 1 minus 2 omega square. Check the option. Check the options, all of you. Now you need to check the options. Question number 57. Question number 57. The real value of theta, for which the expression expression 1 minus sine theta upon 1 plus 2i sine theta is purely real. Purely real is, first option theta is equal to n pi, second option theta equals to n pi by 2, third option theta equals to n pi by 3, fourth is none. Right. The real value of theta for which the expression 1 minus sine theta by 1 plus 2i sine theta is purely real is right. Sin theta equals to sin pi by 2. Right. Purely real. The real value of theta need to be expressed, for which the 1 minus sin theta by 1 plus I sin theta always real, purely real. Purely real means the imaginary part must be equal to 0. Imaginary part of this expression need to be equated to 0, so that we get the trigonometric equation that need to be solved so as to get our solution for theta. Okay, let us solve it now. 57 solution. Let us say z equals to 1 minus sin theta upon 1 plus 2I sin theta. This we need to express in the form of a plus ib form. That means multiply both numerator and denominator with 1 minus 2I sin theta upon 1 minus 2I sin theta. That means we are indirectly, so right, this equals to 1 minus sin theta multiplied by 1 minus 2I sin theta upon, this is nothing but z into z bar mod z square. 1 square is 1, 2 sin theta whole square is 4 sin square theta. So now, since z is purely real, that is imaginary part of z must be equal to 0. Imaginary part, what is the imaginary part? This 1 minus sin theta multiplied by 2 sin theta. So this 1 minus sin theta multiplied with 2 sin theta. So that implies we get like this, 2 sin theta multiplied by 1 minus sin theta should be equal to 0. That means we get sin theta equals to, you will get sin theta is equal to 0. Sin theta is equal to 0 means sin n pi you can write it. Therefore theta is equal to n pi is the answer. So that means first option is the right option. First option is the right option. '58. So these type of questions you might have discussed in your IPE only, IPE questions only. But these type of questions may be asked in the examination. The real value of theta for which simultaneously it cannot become sin x is equal to 1. Simultaneously it cannot become. They are the actually exclusive sense. The real value of theta for which the expression for which the expression three plus 2I sin theta upon 1 minus 2I sin theta is purely imaginary is I already told you simultaneously the both the equations does not hold good. In this case only sin theta is equal to 0 will satisfy. First option n pi, second option n pi plus or minus pi by 2, third option is n pi plus or minus pi by 3, fourth option is none. Okay. Real value of theta means purely the real value of theta we need to find out if the expression is purely imaginary. If the expression is purely imaginary means if the that means actually if the expression is purely imaginary, its the real part is 0. Now real part need to be equated to 0. So let us solve it now. The real value of theta for which this one is purely imaginary. Purely imaginary means real part of, for example, z, this is real part of z should be 0. This is the our plan. So let us do it now. 58 solution. 58 solution. Let z equals to 3 plus 2i sin theta upon 1 minus 2i sin theta. Okay, what shall we do now? We need to express this one in the form of a plus ib. So that means multiply both numerator and denominator with the conjugate of the denominator. Conjugate of the denominator is, yes, everybody knows, 1 plus 2i sin theta. 1 plus 2i sin theta. Here we get 3 plus 2i sin theta multiplied with 1 plus 2i sin theta upon a minus b into a plus b, nothing but a square b square. So 1 square is 1, 2 sin theta whole square is 4 sin square theta. But here actually you remember one thing, according to the problem, since z is purely imaginary, purely imaginary means real part of z must be 0. Let us pick up real part of z. So real part of the z means, you remember one thing, 3 into 1 real part we get 2i sin theta into 2i sin theta, also I square also real part you will be getting. Therefore now we get 3 into 1 3, 2i sin theta into 2i sin theta, 4i square sin square theta. I square is minus 1, 3 minus 4i square, 4 sin square theta by upon this one is 0, cross multiplication 0 you will get it. 4 sin square theta equals to 3. Sin square theta equals to 3 by 4. This we can write root 3 by 2 whole square. So this we can write sin square 60 degrees, pi by 3. In trigonometric equations we have one solution. If sin square theta is equal to sin square alpha, then general solution GS is theta is equal to n pi plus or minus alpha. Therefore we get theta is equal to n pi plus or minus alpha means pi by 3, because this is alpha. This is the solution. Okay, so now this question this question is actually is absolutely you get minus sign, don't worry. Okay, here see, minus sine theta into this 2 sine theta, understood now? Otherwise minus 2 sine theta into 1 minus sine theta. Okay, write on minus, no problem. Multiply minus on both sides, you get this step. Sine theta times 1 minus sine theta equals to 0. Here we get sine theta equals to 0 or sine theta equals to 1. But it cannot satisfy. We need to consider this one. That's why solution is this one. See, this is actually here minus 2 sine theta is coefficient of I multiplied by 1 minus sine theta. We get this one equal to 0. Multiply with our sine theta into 1 minus sine theta is equal to 0 by minus 2, 0. So sine theta is equal to 0, you will get it. Now 59th question. 59th question. Let Z omega be complex numbers such that Z bar plus I times omega bar equal to 0 and arg of Z times omega equals to pi. Then arg Z. First one is pi upon 4. Second one is 5 pi by 4. Third one is 3 pi by 4. Fourth one is pi upon 2. This is the question. Okay. Anybody, what is the answer? What is the 59th answer? Anybody try? Z omega complex numbers. Here omega is not the cube root of unity. Omega is any complex number just like Z only. It may be x plus iy or x minus iy or x1 plus iy. It may be a plus ib. Such that Z bar plus I omega bar. Z bar means conjugate complex number of Z. Omega bar means conjugate of omega equal to 0. Then arg of Z times omega is pi given. This is given. We need to find out argument of Z. Argument of Z we need to find out. Okay, I will try my level best now. This question now. I have the plan like this. Just check it all of you. What is given here? Z bar plus I times omega bar equal to 0. So that implies Z bar equals to minus I omega bar. That implies Z find out. Z equals to again bar. Z bar whole bar is equal to Z. I bar equals to minus I. Minus into minus plus I you will be getting. Is omega. If Z bar is equal to minus I omega bar, Z is equal to I omega, we got it. Now with the help of this condition, arg Z omega is equal to how much given? Pi given. Substitute Z is equal to I omega. So that means now we get arg of, instead of Z, I omega into omega equal to pi. This we can write arg of I omega square equal to pi. Okay. Sorry. We need to find out arg Z, not arg Z square. Wait. I will do the question now. Okay. So with the help of this now, we can have omega value. What is the omega? Z by I. This multiply with I and divide by I. This is I square is minus IZ omega equals to. So now this we can write now arg Z times omega replaces by minus IZ equal to pi. Arg minus I times Z square equal to pi. Right now, this we can write arg of minus I plus arg Z square equal to pi. But arg minus I, argument of minus I is, this is minus pi by 2. So minus pi by 2, arg Z square, just like logarithm, log Z square means 2 log Z. Similar manner, 2 times arg Z equal to pi. Okay, therefore 2 arg Z is equal to pi plus pi by 2. This is 3 pi by 2. Therefore arg Z is equal to 3 pi by 2 by 2, 3 pi by 4. So third option is the right option. Third option is the right option. All of you check it now, your solutions. Okay, thank you, bye bye, see you. So don't worry, I will inform you through the notifications. Okay. Thank you, bye bye, see you.